Have you ever bitten into a lemon and immediately tasted that strong sour flavor? Most people would expect a lemon to taste sour because it contains acid. But imagine eating the same lemon and suddenly tasting sweetness instead. There's no sugar added, there's no candy, syrup, or artificial sweetener. The food itself has not really changed. The reason this can happen is because of a molecule called miraculin. Miraculin can make sour foods taste sweet by changing how our tongue responds to flavor. So, this video is about a strange question. How can chemistry change the way we experience taste? Then, what is miraculin? Miraculin is a protein found in the miracle berry, a small red fruit that comes from West Africa. The interesting thing is that miraculin itself does not taste very sweet. It's not like sugar, honey, or candy. It does not simply add sweetness to food. Instead, miraculin is called a taste-modifying protein because it changes how taste receptors work on the tongue. After someone eats miracle berry, sour foods like lemons, limes, or vinegar can taste sweet for a short time. This makes miraculin unusual because it does not change the food chemically. It changes the way our body senses the food. Before miraculin is involved, taste works normally. When we eat something acidic, like lemon, as acid molecules interact with taste buds on the tongue. The taste receptors detect the acid and send a signal to the brain. The brain then reads that signal as sour. That is why lemons usually taste sharp, acidic, and sometimes unpleasant. The lemon is not trying to taste sour, but our brain is interpreting the signal from our tongue. So, in a normal situation, acid from the lemon leads to a sour signal, and the brain understands that signal as sour taste. Then, how miraculin works? Miraculin changes this process in a very interesting way. First, miraculin attaches to sweet taste receptors on the tongue. By itself, it does not strongly activate these receptors, so it does not taste very sweet on its own. But when acid from a lemon arrives, the environment becomes more acidic. This changes how miraculin interacts with the sweet receptor. Because of that change, the sweet receptor becomes activated and sends a sweet signal to the brain. The lemon is still acidic. Chemically, it's still sour, but the brain receives a message that feels sweet. That's why miraculin is so interesting. It does not turn lemon into sugar. It changes the signal. Humans naturally like sweet flavors. Sweet foods are connected to desserts, fruits, drinks, comfort, and reward. That's one reason sugar is so common in modern food. But eating too much sugar can become a problem. It can be connected to health issues like weight gain, tooth decay, and higher risk of diseases related to diet. This is why miraculin matters beyond just being a fun trick. It raises a bigger question about food science. Can people enjoy sweet flavors while eating less sugar? Miraculin shows that chemistry might help us rethink sweetness, but not by adding more sugar, so by changing how taste is perceived. Miraculin could have useful applications in food science. Because it makes sour food taste sweet, it might help you enjoy healthy foods that are naturally tart or less sweet. For example, sour fruits, plain yogurt, or low-sugar foods could taste more enjoyable after using miraculin. Scientists and food companies have studied miraculin as a possible natural sugar alternative. It could be especially interesting when people who want to reduce sugar intake but still enjoy sweet flavors. However, it's not just about making food taste better. It also shows how chemistry can connect to health, diet, and everyday choices. Even though miraculin is interesting, it's not the perfect replacement for sugar. First, it works best with acidic foods. That means it does not make every food taste sweet. It needs acid, like lemon or vinegar, to create the sweet effect. Second, sugar does more than make food sweet. In baking, sugar helps with texture, structure, browning, moisture, and even how food feels in your mouth. Miraculin can change sweet perception, but it cannot replace all of these jobs. So, miraculin is powerful but limited. It may help with taste, but it does not completely solve the problem of sugar in food. Miraculin shows that chemistry is not only about reactions in the lab or formulas on paper. Chemistry can also change how humans experience the world. One small protein from a berry can make sour food taste sweet. It does this not by changing the lemon itself, but by changing the message sent from the tongue to the brain. That is what makes miracle special. It connects chemistry, biology, food, and human perception. In the end, miraculin reminds us that taste is not just in the food. Taste is also in the way our body and brain interpret chemistry. A tiny protein can have a big impact. Chemistry can change perception.